everybody. Today I'm going to do some more examples of composition and functions, and then I'll throw in an application at the end too. So this isn't meant to teach you composition. There's another video for that, but this is just do a few more problems to make sure you understand how it works. So we're going to start with f of x being equal to 2x plus 1 and g of x being equal to 5x minus 6. And what I want to do is put together f composition g of x. Order is super important here, so you want to make sure you're thinking f of g. So g was 5x minus 6. So this says whatever f says to do, you're going to do that to 5x minus 6. So what f says is whatever I give you, multiply it by 2. So I'm giving you 5x minus 6. So we're going to do 2 times 5x minus 6. And then it says add 1, so we add 1. I really want you to think of it this way as taking what you're given and applying a rule. So the rule is whatever I give you, multiply by 2, add 1. We can simplify that, so let's do 2 times 5x, which is 10x. 2 times negative 6 is negative 12, and then we add 1. Together, this gives me 10x. Negative 12 plus 1 is minus 11, and you can stop. Let's try that with a different one. So this time I have f of x is 3x plus 9, g of x is x squared plus 2x minus 4, and we'll talk about, well, when do I simplify, when do I not? So we start with f composition g means f of g of x. So I'm starting inside with g of x. So let's just write what g of x is. It's x squared plus 2x minus 4. F says whatever I give you, multiply by 3, add 9. So I go 3 times all of this stuff, x squared plus 2x minus 4, and then add 9. It would be okay to stop there. If you want to multiply it through and say 3x squared plus 6x minus 12 plus 9, that's okay. Then you can say that's 3x squared plus 6x. Negative 12 and 9 gives you minus 3. So you have 2 choices. You can do this simplified or you can leave it in the first step. Just to make sure we understand, let's go the opposite way. Let's do g composition f of x. So this time it says we're starting with f of x. So f is 3x plus 9. Now g says whatever I give you, square it, then add to it 2 times whatever I gave you, and then subtract 4. So let's start with, I gave you 3x plus 9, and we're going to square it. Then we're going to take the 3x plus 9, multiply it by 2. And then we'll subtract 4. So we did the squaring, the multiplying by 2, and the subtracting 4. Again, you can stop right there, and that's where I'm going to leave it this time to say you don't have to multiply it out. It shows that you put the 2 functions together, and that's really what we're looking for with composition. So let's try this. I have 4x plus 6, and we're going to do f of f. So that says I'm going to take f of x. Kind of watch the parentheses. Okay, so leave the first f, leave the second f, and the first f is 4x plus 6. So I'm putting 4x plus 6 into the function. So leave this first f alone. We're not touching this one yet. But this second one, it says plug that into 4x plus 6. So I have 4 times 4x plus 6 plus 6. So I took my function and I just kind of plugged it back in. I put the 4x plus 6 where the x was. To make that easier, because I don't want to lose you, let's go ahead and multiply. 4 times 4 is 16x. 4 times 6 is 24. And then we have 6. I can pretty that up a little bit more. There's 16x, 24 and 6 is 30. I think that looks better. Okay, now we're going to do it again. It says whatever I give you, so I'm giving you 16x plus 30. You're going to multiply it by 4. And then you're going to add 6. So it's just repeating now. When you do a composition of a composition, it just means repeat the process. Multiply by 4, add 6. Then whatever you get, multiply by 4, add 6. If you want to, multiply this out. 4 times 16 is 64x. 4 times 30 is 120. I add 6. I have 64x plus 126. So let's just try some more. I have f of x is 1 over x plus 2, and g of x is 9 over x plus 5. So we have f of g. So g is 9 over x plus 5. So now that we have the f of 9 over x plus 5, I need to take the 9 over x plus 5 and put it wherever x is in f. So I have 1 over. Instead of x, I'm going to write 9 over x plus 5 and then plus 2. Part of this will be easy. 5 plus 2 is 7, so I have 1 over 9 over x plus 7. The harder part is we usually don't like to have a fraction within a fraction, and I do have this fraction in the denominator. So what I'm going to do is multiply by x over x. X over x is equal to 1, so I haven't changed the value of anything, but I can change the look of it. In the numerator, 1 times x is x. In the denominator, I'm going to do it the long way. 9 over x times x plus 7 times x. So think here, I distributed this x through the whole denominator. Numerator is x. The 9 over x times x, the x's cancel. I have a 9. 7 times x is 7x, and this is my final solution. Let's look at this one again. Let's go the opposite way. Let's start with f. So I have g of f, so that's 1 over x plus 2. So I'm starting with the f of x first. Now g says whatever I give you, you go 9 over that. So 9 over 1 over x plus 2, and then I'm going to add 5. So really it was just putting this right here and the 9 over x and then add 5 to it. When I divide by a fraction, remember you multiply by the reciprocal, so I have x plus 2 over 1 and then plus 5. I can do 9 times x is 9x, 9 times 2 is 18, and then add the 5 to give me 9x plus 23. Change the functions, do some more. I think again that practice is really how this sets in. So I have f composition g of x. F is x squared plus 6. G is the square root of x minus 4. So I have f of g. G is the square root of x minus 4. F says take whatever I give you, which is the square root of x minus 4, and square it, then add 6. So when I square the square root, those two cancel. I get x minus 4 plus 6. Negative 4 plus 6, I end up with x plus 2. I change the functions. I have x squared plus 3 for f, and I have 2 over x for g, and I switched it to g composition f. I don't want you to get into the idea it's always fg. It could be either one. So this is g. I'm starting with f, which is x squared plus 3. G says whatever you have, you do 2 divided by it. So I have 2 divided by x squared plus 3. This one's done. Nothing else to do. We just move to the next one. So the next one is actually, I kept the same two functions, but I said, what if we do g of x? So we have g of x, which is 2 over x. So g of that, it would be 2 over, put parentheses, 2 over x. This becomes 2 times x over 2. The 2's cancel, and I just get x. So last I want to give you a little bit of application, and it really is just something that I saw when I was out the other night, and I thought, oh, we should talk about that in class. So I went to Tom Segura at the Ratty Shell in San Diego, and before things start, you go to get a drink. So I took a picture of the menu because I thought it was interesting to kind of look overall. You go to buy a beer, and what it says is not the price you pay. So check out the beer, and I went there because it's the easiest one to look at. You don't have choices. You buy a beer, it's $13, but there is fine print. There's a 21% mandatory service charge. 25% of the service charge is going to go to the Ratty Shell. So here's the math part. How can we write this as a function? And if you think I'm being silly, it's not, because someone has to write this as a function in order for this to be programmed for all the bartenders so we can come through and swipe our little credit card and pay, right? So this is important to think about. How can we write this to get it into the computers? So we need to start with a variable like x, and here x is going to be the number of cans of beers that a person buys. And we're going to break this into a couple functions. So b of x will be the cost of the beers. S of x will be the cost of the service fee transaction, and then R of x is going to be how much is the Ratty Shell going to get for the transaction. So we'll see that S composite B will be the service fee for the beers. R composite S of B will be Ratty's share of the sell. We'll take that one thing at a time. So the easy part is the cost of the beers, B of x. So B of x will be equal to 13x. Every can of beer costs $13, so how many cans you buy times 13, there's our total. The service fee, and it's hard to see in this picture, is 21%, but this S of x will be 0.21 times x. So here, x is going to be whatever cost that we're going to put into it. And we'll kind of see as we go in. And then the Radical, they're getting 25% of the service fee. So this is 0.25x. So it's when we put this all together that it really makes sense. Standing alone, it doesn't make sense that we could have the same x for each of these. So let's start thinking about this all together. If I want to find this, like how much service fee do I have for the beers? So we do S of B of x. This is S of B of x, which is 13x. Then S is you do 0.21 times 13x, which is equal to 2.73. Now, I want you to think about this. 2.73x, you're paying an additional $2.73 for every beer that you buy. So say you come in and you buy 2 beers. So B of 2 would be 13 times 2, which is 26. But then you have the service fee, S of B of x, which in this particular case is S of B of 2, is 2.73 times 2, which is 546. So when you're looking at it, it means these 2 beers altogether are $26 plus $5.46, which is $31.46, which seems like a lot of money just to buy 2 beers, right? It's a kind of surprise fee that you don't know when you walk up that you're paying the $5.46. What is Radical getting out of it? Well, we said that the S of x, 0.26, and the B of x, 13x, and then the R of x is 0.25x. So we put it all together. So we have R of S of B, which is R of S of B. And we kind of know the first part. We just did that the S of the 13x comes out to be 2.73x, right? We did that in the last step. This S of B was 2.73. Now we're going to put in front of that a 0.25 of 2.73 times x, which is 0.6825 of x. So this says for every beer that's sold, the Radical is going to get about 68 cents. So this is R of S of B of x is 0.6825 of x. So what does that say for what we just said, where we looked at buying 2 beers and it cost $31.46? That says if we put the 2 into this R of S of B, this is about, we're going to just round that to 1.37. So of the $31.46 that we pay, $1.37 would go to the Radical as part of their fee for kind of being the host of the whole thing. Now, if you're thinking maybe we should have another function that tells us the total we pay like right away, you're right. Our total could be expressed as B of x plus S of B of x, because we have to know how much was the item you are getting plus what is the service fee. So hopefully this was good to see a few more examples done, and then to really see where people could use this in the real world. Hopefully helps set it in your head as well. Good luck.